Hi students, how are you all? I think everybody are good and you are learning mathematics very well. So for the extension of previous classes, today we are going to discuss about trigonometry exercise 11.3 important model questions. First bit, first problem, second, third, fourth, fifth. These are important model questions for public examination, and this exercise can be done with the previous knowledge, that is specific angle tables related complementary angle property. Understood? Once again I will revise that one as a simple point. What are complementary pairs here? Here we know that sine theta cos theta are complementary pair to each other. Secant theta cosecant theta are complementary pair to each other, tan theta and cot theta are complementary to each other. So that's why their property will be sine 90 degrees minus theta is equal to cos theta, we can write. Okay, or the same thing can be written as cos 90 degrees minus theta can be written as sin theta. Left to right we can write, or right to left we can write. This is first pair property. Coming to the second pair property, we can write it as secant 90 degrees minus theta is equal to cosecant theta, or the same thing can be written as cosecant 90 degrees minus theta as secant theta. That is the second pair property, complementary property. And the third one is tan 90 degrees minus theta can be written as cot theta, or same thing can also be written as cot 90 degrees minus theta is equal to tan theta. So this concept is enough, this simple concept is enough to solve the important model questions of this exercise. These models are important for 1 mark bits and 2 marks problems only. 4 marks, 6 marks model questions will not ask from this type. Got it? How we will use this complementary pair relation to solve these exercise problems, we will come to know, right? Okay, what are those important model problems? First bit, first and second questions I am taking. They are asking evaluate tan 36 degrees by cot 54 degrees. Means they want to simplify this. How do we do? Solution. You just observe the question. There will be a interrelation to apply the complementary property. What is that? Tan cot are reciprocal pairs as well as complementary pairs, but which is suitable to solve the problem, that one we have to recognize. For that, obviously we need to check the angles. Here 36 degrees, here 54 degrees. Sum of these two angles is 90, so we have a chance to apply complementary property. Sum of two angles is 90 means those are complementary angles. So complementary property is suitable to simplify, to evaluate this one. How do we write? So write the numerator as it is tan 36 degrees by cot 54 degrees as it is as a question is equal to numerator, take it as it is tan 36 degrees, change the denominator in terms of tan. For that, what property we have? We have cot theta can be written as tan 90 degrees minus theta, means cot theta equal to tan 90 minus theta, means complementary function with complementary angle gives you equal answers. Understood? Complementary function with complementary angle gives you equal answer. That's why cot 54 degrees will be written as tan complementary function with its complementary angle is 90 degrees minus 54. Understood, Nana? Habituate to write it like this: complementary function with complementary angle, that equal to tan 36 remain as it is by this will become tan 90 degrees minus 54 is 36 degrees. So both numerator and denominators are having same value, so therefore it is equal to 1. Understood? So what I did is I kept numerator as it is. I try to convert the denominator in terms of numerator trigonometric ratio. So that's why I got the answer like this. Same problem can be done. You can change the numerator into its complementary cot by remaining the denominator as it is. Understood? Then numerator will become cot 54. Denominator comes as remains as cot 54. Both will get cancelled. You will get answer same 1. Understood? Right. Come to the second problem. What they are saying, they want to evaluate cos 12 degrees minus sin 78 degrees. So as I said here, if there are interrelated complementary trigonometric ratios, remain one as it is, change the other. Understood? So as a solution, I am taking this one as it is, cos 12 degrees minus sin 78 degrees will be simplified as, I want to write this one as it is, cos 12 degrees minus, I want to apply complementary property here. Understood, Nana? So how I can apply, recall the formula, write the formula is compulsory. It look like sin theta. Sin theta is equal to complementary function cos with complementary angle 90 degrees minus theta. Understood? So this will become complementary function, its complementary angle is 90 minus 78 degrees. Got it? So write it as it is, that equal to cos 12 degrees minus this is also cos 90 minus 78 means 12 degrees. So both the terms are same, under subtraction they will get cancelled, therefore we will get additive identity 0. That is the answer. Understood, sir? So I have taken first term as it is, I changed the second term. Understood? You can do in the other model also. You can change the first term into complementary function by remaining the second term as it is, but you will get the same answer 0. Got it? Right. Okay, ma. Now observe that second problem. These model problems also very important for bits and 2 marks questions. Very simple, just 1 minute is enough to solve them. What they are asking, second question, show that tan 48 degrees into tan 16 degrees into tan 42 degrees into tan 74 degrees equal to 1. This is the first question. In the same way, that one is the second question. How to solve them? Since they are asking to show this value equal to 1, under solution you take LHS. LHS is equal to tan 48 degrees into tan 16 degrees into tan 42 degrees into tan 74 degrees I have taken. Clear, Nana? Right. In this, to solve means to make it as equal to 1, observe the interrelation between the angles. What is that? Here 48 degrees, 16 degrees, 42 degrees, 74 degrees are the angles. Clear? In this, if you observe that 48 degrees plus 42 degrees will gives you 90 degrees. Sum of two angles equal to 90 means both are complementary angles. So try to apply complementary relation between the trigonometric ratios. For that, write one term as it is, change the other. Okay, in the same way here 16 degrees 74 degrees, sum is also 90 degrees, both are also complementary angles. So write one as it is, change the other into complementary property. So I want to take these two terms as it is, and I'm going to convert these two into complementary property. I want to change these two into their complementary functions. Okay, how, what condition I will use? I know that, we know that tan theta is equal to cot 90 degrees minus theta. Complementary function with complementary angle gives you equal answer. That's why this will become complementary function cot 42 degrees. Complementary relation is 90 degrees minus 42 degrees. Got it? Into this one also cot 74 means 90 degrees minus 74 degrees. Clear? Right. Now try to simplify them. This is equal to first term, second term as it is, tan 48 degrees, right, into tan 16 degrees into cot 90 minus 42 degrees means 48 degrees into cot 90 minus 74 degrees means 16 degrees. So two terms are converted into their complementary functions. They simplified. Here we know one property. That one is tan theta into cot theta is equal to 1 under the reciprocal property. That's why tan 48 into cot 48 will become 1 into tan 16 into cot 16 will become 1. That is equal to 1 using this property. Got it? Therefore, this 1 is nothing but RHS. So we can conclude that therefore LHS is equal to RHS. That's it. That much simple. It is a weightage of either 1 mark bit or 2 marks question. In the same way, we will take the second question. What they are saying here, cos 36 degrees into cos 54 degrees minus sin 30 degrees 36 degrees into sin 54 degrees equal to 0 we have to show. So as usually under solution take LHS. LHS is equal to cos 36 degrees into cos 54 degrees, okay nana, minus sin 36 degrees into sin 54 degrees. That is LHS. So how do we simplify? I want to take these two terms as it is and I would like to apply complementary relation for these two terms. Okay, how it will come? This is cos 36 degrees as it is into cos 54 degrees also as it is minus sin 36 degrees into sin 54 degrees are going to change using complementary property. What is that? We know that sin theta is equal to cos 90 degrees minus theta, right? Then this will become complementary function cos with its complementary angle 90 degrees minus 36 degrees into this one also same. Okay nana, cos complementary function with 54 degrees complementary angle 90 degrees minus 54 degrees. Okay nana, first two terms I have taken same minus next two terms are converted into complementary functions using this property. Okay, now just simplify it to get the answer. Cos 36 degrees into cos 54 degrees as it is minus this will become cos 90 degrees minus 36 means 54 degrees into cos 90 minus 54 means 36 degrees. Got it sir? Now you see cos 36 into cos 54 minus cos 54 into cos 36. Just commutative property model, a into b minus b into a, so both are same values, they get cancel each other under subtraction, therefore answer will become 0 which is equal to RHS. Therefore we can conclude that LHS is equal to RHS. Our requirement is over. In this simple way you can do these type of questions using complementary properties, right nana? Okay ma, now observe the third problem. This model is also important nana for 2 marks. In this model what they are saying, if tan 2a is equal to cot a minus 18 degrees where 2a is acute angle, find the value of a, find the measure of angle a. Very simple problem nana. So solution will become, given tan 2a is equal to cot a minus 18 degrees. Okay, There are so many models to solve this one, simple things only, but among them one process I am applying. What is that one? Complementary property only, but I would like to convert tan in terms of cot, remaining this RHS same. So for that one we know that tan theta is equal to cot 90 degrees minus theta. This one I would like to apply in LHS. Then it will become complementary function cot with its complementary angle 90 degrees minus 2a is equal to right side as it is, no change, cot a minus 18 degrees. Got it, Nana? Now by this LHS equal to RHS, both are cot ratios, cot trigonometric functions, and becoming equal means their respective angles are equal. Understood? Their respective angles are equal. That's why it implies 90 degrees minus 2a is equal to a minus 18 degrees. Okay, Nana? Get a values at one side. This implies minus 2a minus a is equal to minus 18 degrees, and this will be become other side as minus 90 degrees. Got it? Therefore this implies minus 3a is equal to minus 108 degrees. Minus minus get cancelled and 3 table get cancelled them. 3 3s are 9 and 18 will remain. 3 6 are 18. So after 3 table cancellation we got a value as 36 degrees. That's it. This is the answer. That much simple. Okay, Nana? Okay, ma. Now observe that the fourth question, almost same process as third question. What is that question? If tan A is equal to cot B, where A comma B are acute angles, prove that A plus B equal to 90 degrees. Very simple process like the third one. What you have to do? Given tan A is equal to cot B. This implies I want to remain tan A as it is equal to, this is going to be written as in terms of tan using complementary property, that is complementary function with its complementary angle 90 minus theta. Theta means here it is B. Understood, Nana? So first term taken as it is equal to, second term is applying complementary property. So complementary function with complementary angle. That means write that condition. Cot theta is equal to tan 90 degrees minus theta. This rule is applied. Now just simplify. Both are tan ratios and they are becoming equal means their respective angles are equal only na, under acute angle property. So A is equal to 90 degrees minus B. Got it, Nana? So this implies, send this B to this side, A plus B is equal to 90 degrees. That one is proved. So hence proved our required condition, A plus B equal to 90 degrees. Got it? Right. Okay, ma. Now we are going to discuss about the last important model of this exercise. These model problems are very important for examination point of view. So listen to me carefully. What is that question? The fifth question is, if capital A, B, C are interior angles of a triangle ABC, then show that tan of A plus B by 2 is equal to cot C by 2. Okay, very simple to solve, just for 2 marks. 2 minutes is enough to solve this one. So how do we do? Solution. In triangle ABC, by using angle sum property, the interior angles will follow. A plus B plus C is equal to 180 degrees. Sum of the three angles equal to 180 degrees. Okay, this implies we can divide the total terms with 2. Then A plus B, now we can convert this one into our required condition. For that, this implies A plus B is equal to 180 degrees minus C. Got it? Next step, for our convenience, I am writing it as A plus B by 2. means dividing with 2 the left side. So do the same thing on the right side. Is equal to 180 degrees minus c by 2 will come. Got it? Right. Now apply tan on both sides. Apply tan ratio on both sides. Then it will become tan of a plus b by 2 is equal to tan of 180 degrees minus c by 2. Got it? Now I had LHS of our requirement. So I will remain this one as it is, and I would like to convert this RHS part into our required condition. So what do we do? This will equal to tan 180 by 2 will become 90 degrees minus c by 2 is as it is. Got it, Nana? Now tan 90 minus theta means cot theta. Here theta value is c by 2. Therefore, we got it as complementary function with its complementary angle. So condition also I am writing here. This is equal to tan 90 degrees minus theta equal to cot theta. Got it? Under that I got cot c by 2. Therefore, final conclusion, tan of a plus b by 2 is equal to cot c by 2. We get it. Okay. So in this model, by remembering the complementary properties, easily we can convert any of these model questions. Okay. Practice well, get good grades. Thank you.